These objects are not required any introduction. Yes? Alright. When do we use these spectacles? Exactly. When we have a vision problem. In this video, we are going to discuss defects of vision, reasons and their correction. As we learnt, near point and far point of a healthy person is 25 cm and infinite respectively. It means that healthy person can see near and far objects clearly. But some people cannot see near objects clearly. Some people cannot see far objects clearly, and few people cannot see near and far objects clearly due to vision problem. Let us discuss the defects of vision. There are major 4 types of defects. First one, myopia. It is also known as short-sightedness. Second one, hypermetropia. It is also known as long-sightedness. Third one is presbyopia, and fourth one is astigmatism. Let us discuss about myopia. A person suffering from myopia or short-sightedness can see nearby objects clearly but cannot see the far objects clearly. In this case, light from a distant object is focused in front of the retina. So the object is not seen clearly as it is forming image in front of the retina. The reasons for this is either the eyeball is longer than the normal, or the maximum focal length of the lens is insufficient to produce a clearly formed image on the retina. This kind of problem can be corrected by using a suitable lens. Here we have 2 types of lens. One is convex lens and another one is concave lens. Then which kind of lens to be used? So the problem is these persons cannot see far objects. If the far objects are closer, then these people can see. The lens which forms distant object image very near is concave lens. So to correct myopia, we use concave lens. When concave lens is placed, the distant object forms image at the far point of the person. Let us say it is as F. So this image acts as object for the eye lens for myopic eye, and it forms on retina, so that the myopia can be corrected by using a suitable concave lens. Now, what could be the focal length of this concave lens? This can be calculated very easily. For a normal human being, the far point will be infinite and the near point is 25 cm. But in this case, the far point is not infinite distance. It is the point up to which he can see clearly, that is point F. So the distance between the point F and the eye lens is x. So this x is known as far point. So the object distance is equal to infinite distance and image distance is equal to far point, as the image is going to form at far point. By applying sign convention, u is infinity and v is minus x. From the formula 1 by f equal to 1 by v minus 1 by u, if you substitute and simplify, we will be getting f value as x. Okay, here we got f value as minus x. Minus indicates it is a concave lens. So the focal length of the lens to be used is equal to the far point of that person. Here is a problem for us. The far point of a myopic person is 80 cm in front of the eye. What is the power and nature of the lens required to correct the problem? So as it is given myopia, the nature of the lens is concave, already we know that. Here the problem is the person cannot see the objects which are beyond 80 centimeter from him. If an object is at 90 centimeter, he cannot see the object clearly. If the object is at 70 centimeter, he can see it. So his far point is 80 centimeter. Generally far point will be infinite for a healthy person, but for this person it is 80 centimeter, not infinite. So the far point is x is equal to 80 centimeter. For myopic eye, focal length of the lens is equal to minus x. Already we have seen in the previous. Therefore, the focal length of the lens is equal to far point of that person, that is minus 80 centimeter. Then how to calculate power? Power is equal to 1 by focal length if the focal length is in meter. If the focal length is in centimeter, then it is 100 by f. That is the formula for power and focal length. So power is equal to 100 by focal length is minus 80. If you simplify that, then we will be getting its value is minus 1.25 diopters. What is D here? Diopters. It is the SI unit of power of lens. So the power of the lens used to correct this problem is minus 1.25 diopters, and the lens is used to correct this one is concave lens.